Good morning, dear student. Today we solve the problem related to vapor compression cycle. This is the problem related to vapor compression cycle. A refrigeration machine is required to produce at a 0 degree centigrade from water at 20 degrees Celsius. The machine has a condenser temperature of 298 Kelvin while the evaporator temperature is 268 Kelvin and the relative efficiency of machine if 50% and 6 kg of freon R12 refrigerant is circulated through the system per minute. The refrigerant enters the compressor with a dryness fraction of 0.6 and the specific heat of the water is 4.187 kilojoule per kg Kelvin and the latent heat of the ice is 335 kilojoule per kg. Calculate the amount of ice produced on 24 hours. And the table of the property of freon is given below. Okay, this is a table. In that is the temperature, and it is a liquid heat or a liquid enthalpy, and it is a latent heat of vaporization, and it is an enthalpy, and it is an entropy of liquid of a substance that is circulated inside cycle. Okay, so in that problem, first of all, what data is given. देखिए इस प्रॉब्लम में जो हमें डाटा दिया है वो m इक्वल टू 6 kg per second. It is a mass flow rate of refrigerant that is circulated in 4 parts, that is compressor, condenser, throttling device and evaporator. These are 4 components, and that is flow of the mass is 6 kg per second minute, and eta is the relative efficiency 50%. X2 is the dryness fraction at the entry of the compressor. CPW is the specific heat of the water, and latent heat of the ice is 335 kilojoule per kg. From figure and above this table, first of all we have some data is written as HF2. It is the liquid enthalpy at point 2 equal to 3. It is the liquid enthalpy 314 at a particular temperature 268, that is the evaporator temperature. Okay, and a particular 268 temperature, and the latent heat is 154. It is the HFG2. Okay, and HF3, it is the liquid enthalpy at point 3, that is the uh, inlet of the condenser. HFG3, it is the latent heat of at point 3, and HF4, it is the liquid enthalpy at point 4. So first of all, solve this problem. We have to find the 4 point in that cycle, and we have to know about the enthalpy of each and every point. Then we can find easily what you need. Okay, so we have to find the H2 value. So you see, you can I make a TS diagram of this cycle. Okay, TS diagram. Okay, this is the TS diagram. It is a rough diagram. Okay, this is the 1, and this is 2 point, and it is 3 point, and it is 4 point. So 1 2 3 1 2 3 4 point. 1 to 2 is evaporation process, and 2 3 is the condenser process, sorry, compressor process, and 3 4 it is a condenser process, and 4 1 it is a throttling process. Okay, so first of all we have to find the value of the enthalpy at 2 point. So we have need a liquid enthalpy, and it is latent heat, and at that point 2, what is the drainage fraction value? It is the x2, and the x2 value is already given in the questions. So we have to put the value hf2 and drainage fraction and its latent heat, and then 123.8 kilojoule per kg, it is the enthalpy at point 2. Okay, at point 3 we have to find the enthalpy also, but we have not know about the drainage fraction at that point 3, that is the x3. So first of all we have to find the drainage fraction, but we know about that the process 2 3 is isentropic process, so that the entropy before and after that is same. So S3 2 3 is isentropic compression process, so S3 equal to S2, S3 equal to SF3 plus X3 HFG 3 divided T3, it is the HFG, sorry, SFG3. Okay, SFG3 का जो वैल्यू है वो HFG3 डिवाइडेड T3. ओके, और S2 इज इक्वल टू हो गया SF प्लस X2, और HFG2 डिवाइडेड T2 इज SF2. Okay, so we have known about there is always known, but x3 not did not know. Okay, so it is unknown, so we have find the value of x3. then after hf3 equal to hf3 plus x3 hf3 g3 hf3 equal to hf4. Okay, and the value is known. Wait, hf3 value is, put of this value 59.7, and x3 it is already calculated, and hfg3 it is 138, and then calculated 133.2. The value of h1 equal to hf4, because h1 4 sorry 1 to 4 it is isenthalpic process, so enthalpy is same for these point. Okay, so throughout this problem we have to find the enthalpy at all 4 points. Okay, find the enthalpy of all the 4 points. So theoretical COP, what is the formula? It is the refrigerating effect. Rn is the refrigerating effect divided work done to the compressor. So refrigerating effect in which process? It is the evaporation process. evaporation process enthalpy difference हो गया आपका H2 minus H1, और वर्क डन हो रहा है आपका प्रोसेस 2 से लेके 3, तो एंथैल्पी डिफरेंस जो भी होगा वही उसका वर्क डन होगा. Okay, put is these enthalpies and find the theoretical COP 6.98, sorry 6.82. In that question the efficiency of relative is given, so we have find the actual COP of this system. So relative multiply theoretical, and then 3.14, it is the actual COP of the system. Okay, Next, the heat extracted from 1 kg of water at 20 degrees Celsius for the formation of 1 kg of ice at 0 डिग्री सेल्सियस। आपके पास 1 kg वाटर है जिसका टेम्परेचर 20 डिग्री सेल्सियस है, जिसको हमें कन्वर्ट करना है 1 kg की बर्फ़ में, जिसका टेम्परेचर 0 डिग्री सेल्सियस है। ठीक है, तो कितना हीट आपको निकालना पड़ेगा। सो 20 डिग्री से हम 0 डिग्री सेल्सियस जाएंगे, फिर 0 to 0 सेल्सियस की हमें आइस होगी। ओके, तो 1 into specific heat of the water, 20 minus 0 plus latent heat of the ice. So it is the amount of heat for 1 kg of water that is extracted from that water. So m is the ice equal to mass of ice formed in kg per minute. Okay, COP of actual equal to 3.1441 and equal to Rn is the actual refrigerating effect divided work done. So refrigerating effect it is also equal to the rate of ice formation multiply the latent heat of the heat extracted from the ice. So m is the mass of the ice, that is the okay. Rn it is the actual refrigerating effect divided W, that is the work input to the compressor. So refrigerating effect in actual is basically describe how much ice is generated kg per minute and how much heat is extracted from the water. It is a multiplication. Okay, so mass of ice into 4.18 into 74, it is the amount of heat that is extracted from 20 degree Celsius of water to convert into 0 degree Celsius of ice. It is the amount of heat divided m bracket h3 minus h2 bracket close. It is the compressor input. It is already we have to calculate it. Okay, put up these value. There is only one unknown. It is the m ice. It is unknown. All the parameters given. So put all these value of these parameter and one unknown. It is find that. So m ice equal to 0.0459 kg per minute. It is the mass of the ice formation in per minute. So we have to find in 24 hours how much ice is generated. So in 24 hours we have to calculate it in ton. So it is 110, you know that the 1000 kg. Okay, in 10, 0.661 ton is the ice formed in 24 hours. Okay, next question. It is a 28 ton of ice from and at 0 degree Celsius it is produced per day in a ammonia refrigerator. The temperature range in the compressor is from 25 degrees Celsius to minus 5 degrees Celsius, 15 degrees Celsius, and the vapor is dry and saturated at the end of the compression, and the expansion valve is used. Assume coefficient of performance of 62% of theoretical. Calculate the power required to drive the compressor. It is a very easy question. In that question, compressor inlet temperature is minus 15 degrees Celsius and the outlet of the compressor temperature is 25 degrees Celsius. Okay, we have to define the output. हमें जो आइस का प्रोडक्शन चाहिए वो 28 टन चाहिए और वो भी 0 डिग्री सेल्सियस और एक डे के अंदर। और अमोनिया क्या है, एज ए रेफ्रिजरेंट यूज़ किया गया है इसमें। So this is the property of the ammonia at a particular temperature, 25 degrees Celsius. It is the compressor outlet temperature, and minus 15 it is the compressor inlet temperature or the exit of the evaporator. These are the liquid and vapor enthalpy, 100.04. These are the enthalpy in that given the table, and the take latent heat of the ice well is given. So this table is ammonia refrigerant. Okay, so first of all, see we see the TS diagram of this system. 1, it is the inlet of the evaporator, and 2 is the exit of the evaporation, and 2 point is the inlet of the compression also. 3 point is the outlet of the compression system, and 4 is the condensation exit point, and 4 also inlet of the throttling or expansion process. So it is the upper temperature, it is the lower temperature converted into kelvins. So H3 it is a dry saturated. 3 point, it is already say that in question it is a dry unsaturated, so we have to check the enthalpy directly at a particular temperature to 25 degrees Celsius. At a 25 degrees Celsius, 3 point is a vapor, so we choose the enthalpy this, it is the H3 value. Okay, 1319.22. okay, or where H1 equal to HF4. So enthalpy at 0.4, it is a saturated liquid, so saturated liquid enthalpy we can see at a correspondence value as 25 is 100.04. it is the liquid enthalpy of the 4 point. So H4 equal to H1, then it is the value of enthalpy is 100.04. okay, so there is a one problem we have doesn't know about the at a 2 point what is the dryness fraction value. Okay, at 2 point the refrigerant is in form of liquid and vapor. So finding the enthalpy at 2 point, we have to know the what is the dryness fraction value. So we have not know about the dryness fraction, but 2-3 process is isentropic process. So entropy at S2 equal to S3. So S2 equal to SF2 plus X2, SFG2 equal to SG3. So 3 point is a gas or a vapor. So SG for gas. Okay. So from table we have take the value of 2 point. 2 point is the temperature is minus 15 correspondence. Liquid entropy, it is given in minus 2.1338, and the dryness fraction at 0.2 we have not know about, so it is calculated. And SFG2, so SFG2 equal to SG2 minus SF2. So vapor enthalpy, it is given at minus 15 correspondence, and vapor and 5.058, it is a vapor entropy at particular temperature is minus 15 correspondence, and it is a liquid entropy correspondence to minus 15. So further calculate, the value of x2 is calculated is 0.92, So H2 equal to HF2 plus X2 plus multiply SFG2. So SF sorry HF2, take the value from the table, add a correspondence value minus 15. It is minus 15.44 0.56 and X2 0.92, or HFG2, it is a Hg2 minus HF2. So HF2, it is a liquid enthalpy at minus 15, Hg2 minus 15. Put up these values and find the value of H2. Next, theoretical COP of the system. The theoretical COP of the system, it is a refrigerating effect divided work done. So mass in the numerator and denominator is same. So enthalpy at the above, and that is the refrigerating effect is H2 minus H1. It is the H2 and it is H1, and Warden process that H3 minus H2. Put these values of enthalpy and find the value of COP theoretical. And actual COP is, it is a multiplication of the theoretical COP multiply relative efficiency that is given in questions, and this is the actual COP of the system. Okay. Next, actual रेफ्रिजरेटिंग इफेक्ट पर केजी. देखिए हमारा जो सिस्टम है वो कितना रेफ्रिजरेटिंग इफेक्ट दे रहा है पर केजी रेस्पेक्ट. तो COP of actual equal to refrigerating effect divided burden. So the actual refrigerating effect per kg equal to COP of actual multiply burden. So actual COP we have already calculated and burden have already calculated, so we have find the actual refrigerating effect. So heat extracted per hour, आपने 1 घंटे में कितनी हीट आप एक्सट्रैक्ट कर सकते हैं. ओके, so that is the 28 is what is that? It is the capacity of the system, and 28 ton 1000 kg of water in a one day hour कितना हो गया 24, और 335 is the latent heat. So that is the heat value that is extracted from that. Okay, this is the capacity of the system that is extract the heat from that any stuff. Okay, per second we have to find, so divided by 300 3600 and heat extracted per second, that is values. So what at that is the heat extracted हो गया. अब क्या है, मास ऑफ रेफ्रिजरेंट पर सेकंड कितना सर्कुलेट होगा उसकी वैल्यू हमें कैलकुलेट करना है. तो ये हीट एक्सट्रैक्टेड पर सेकंड डिवाइडेड करना है एक्चुअल रेफ्रिजरेटिंग इफेक्ट से. तो ये हमें पता लग जाएगा, ये 0.1599 किलो kg per second. It is the mass of refrigerant circulated. So work done by the compressor per second कितना हो गया? It is the mass flow rate of the refrigerant multiply enthalpy difference of output point and inlet point. So it is the mass of the refrigerant flow rate, and H3 is the exit point of the compressor enthalpy, and H2 is the inlet entry of the compression enthalpy. So put in these values, find the value of the compressor burden per second. So it is a kilojoule per second. It is converted into kilowatt. 1 kilojoule per second is 1 kilowatt. Thank you all of